Hello students, myself Mayur Patil, and today I am going to explain the topic Introduction of TOC. TOC stands for Theory of Computation. It is also known as flat, TCS or AT. Flat stands for Formal Language and Automata Theory. TCS stands for Theory of Computer Science and AT stands for Automata Theory. TOC is a fundamental course in a computer science. TOC is the most fundamental course in a computer science. The next point is the definition of TOC. What is the meaning of Theory of Computer Science? Okay, so TOC is a basic branch of computer science and it deals with how the problem can be effectively solved by computation model using an algorithm. What is the definition of TOC? The definition of TOC is that the basic branch of computer science which deals with how the problem can be solved by the computation model using an algorithm. Or the second definition of TOC is the TOC is a theoretical branch of computer science and mathematics which deals with computation logic. Okay, so both definition says that the TOC is nothing but a fundamental branch of computer science and it only deals with the computation logic. Okay, now let's see what is the meaning of theory. What is the meaning of theory? So, theory is nothing but the capability of machine. Theory is nothing but the capability of machine. What type of problem can be solved by the machine? What are the limitations of a machine? What are the properties of a machine? What are the benefits of a machine? So, all these things are grouped into the term and that term is known as a theory. Now, see what is a computation. So, computation is nothing but a task is performed by the computation device. Computation is nothing but a task is performed by computation device like calculator, computer, etc. For example, suppose I want to perform a task 2 plus 2 and I have a calculator. I just type 2 plus 2. Calculator gives me the answer 4. Calculator gives me the answer 4. In computation, this is known as input and the answer is known as output. Okay. Now, the third point says that it is mainly about what kind of things can you really compute mechanically. It is mainly about what kind of things can you compute mechanically. So, to explain this point, I will take one example out of this. Okay. Suppose we have to design a machine. Suppose we want to design a machine which accepts a binary number whose last digit is 0, or we can say design a machine which accepts a binary number which ends with 0. Suppose there is a 3 input 1 0 1 1 0 0, then 1 1 1 0 1 0 and 0 0 1 1 1. These are the 3 inputs. So how we can identify so the string is accepted or not? Okay, so we directly focus on the last bit. Okay, it is 0, accepted. Again, second input, okay, last bit is 0, okay, accepted. But when we observe the third input, the last bit is 1, and we can directly say that this input is not accepted because it is not valid, or it is invalid. How this task is performed by the machine? Machine also focus on the last bit. Machine also focus on the last bit of the given input string. If the last bit is 0, accepted. If the last bit is not 0, not accepted or rejected. Okay. Now take second example. The second example is what? Design a machine which accept all valid C statement. Design a machine which accept all valid C statement. Okay, now how we design this machine? C statement. So C is a programming language. There are so many programming languages: C, C++, Java. Okay, now each and every programming language having syntax and semantics. Okay, so if we want to design a machine which accept all valid C statements, so what are the valid C statements? See, printf. This is a valid C statement. Scanf. This is also a valid C statement. But instead of this printf, if we write P is a capital printf like this, so at this point, whenever machine comes, machine struck and gives the error, because the default syntax and semantics of printf is not matched. Now, what the third point says? The third point says, I again take one example. Now, the third point says that what kind of things can you really compute mechanically? Suppose the third example is that design a machine which accept all valid C statements and never goes into the infinite loop. Okay, suppose we want to design a machine which accept all valid C statement and which never goes into the infinite loop. So up to this statement we are fine. Okay, machine working well, all the inputs are accepted. Okay, but the second statement says that never goes into the infinite loop. How the machine decide that the code is not goes into the infinite loop? This task is not checked by mechanically. So this point says that it is mainly about what kind of things can you really compute mechanically. We can compute mechanically what is the output of the given program. Okay, fine. But we cannot say that after executing the program goes into the infinite loop. Okay, so this is this third point. This is the third point. Okay, now the TOC is again classified into three categories. TOC is again classified into three categories. Which are they? Let's see. So TOC is classified into three categories. First one is automata theory. First one is automata theory and language. First one, automata theory and language. What is the meaning of automata theory and language? So this automata theory and language deals with definition and the properties of various mathematical model like FA, CFG and TM. What is automata theory and language? So automata theory and language deals with the definition and the property of various mathematical model like FA stand for finite automata, CFG stand for context free grammar, and TM stand for Turing machine. Okay, now second one is what? What is second group? Second group is computability theory. Second one is computability theory. Second one is computability theory. So what is the meaning of computability theory? So computability theory deals with what type of problem, can be and cannot be computed by the model. Computability theory says that what type of problem can be and cannot be computed by the model. And the third one is complexity theory. Third one is nothing but complexity theory. Okay, in complexity theory, this point groups the this point groups the computable problem. This point groups the computable problem based on their hardness. What complexity theory does? The complexity theory groups the computable problem based on their hardness. So how the problem is hard? Whether the problem is very easy, somewhat easy, or hard, or very hard. On this basis, the complexity theory groups such types of problems. Okay, so these are the three parts of the TOC. First part is automata theory and language. Second part is the computability theory, and third part is the complexity theory. Now let's see what is the aim of theory of computation. Let's see what is the aim of theory of computation. So aim of TOC. Aim of TOC. What is the aim of TOC? So aim of TOC is to develop a formal mathematical model mathematical model of computation, mathematical model of computation to develop a formal mathematical model of computation which reflects a real world computer, real world computer. What is the aim of TOC? theory of computation. The subject aim of this subject is what? To develop a formal mathematical model of computation which reflects a real world computer. Means what? In this subject, throughout this video lecture, what we do, we design a machine. Okay, we design a machine, we design a mathematical model. We design a mathematical model, gives input to that mathematical model of the machine thing. What action to be taken on the given input, and after taking the action with the help of algorithms, the model provides output either yes, either no. Yes means what? The given input is accepted. No means what? The given input is not accepted. So this is a introduction of the subject theory of computation. If you like this video, please comment your comment in the comment box. Your comments and suggestions are valuable for me, and please subscribe my channel. Thank you.